So without waiting, we just should we move on lah? Okay, to the questions. So today basically we do the 11th question lah. Okay, so and then after that I will send the answer to the group lah. Okay, so let's look at question one because today also takes a long time. So I'm trying to make this like as short as possible lah. Okay, do not keep it here for so long. So yeah, look at this is SPM 2021 paper 2. Okay. So let's look at question 1. Okay. Question 1 is form 4 chapter 2. Okay. So table 1 shows the proton number and nuclear number of atoms X and Y. The letters X and Y are not actual symbol of the atoms. Okay. So I saw some of you form 4 chapter 2 still can't score. Okay, even though only got 5 marks. Okay, but it should be 5 out of 5 lah. Okay, so or at least 4 out of 5 or 5 out of 5. Okay, it's better for you lah. So, and then what is meant by nuclear number? Okay, so there is also SPM. Sometimes they ask meaning of proton number, meaning of isotope in this chapter. So let's write down. Okay, so what's the mean? Okay, the total number, or you can say sum also can. The sum of the number of proton also can. Sum or total, same thing. The total number of protons and neutrons in the nucleus of an atom. So this is first mark. Yeah. Then B, state the number of protons in atom X. Okay. So look at this. They given you in table. You got two different elements, atom X and Y. So in this case, the proton number is for X is 8, nuclear number is 16. So they want the number of proton. So obviously, okay, this is the free mark. Okay, for X is 8. This is the free mark. Okay, absolute free mark. Okay, write the standard. Everything like this. Unfortunately, no. Okay. So 100 question. Write the standard representation for atom Y in the form of AZY. So if you see remember this part, right? The AZY part. Today is still the key. No. Okay. So you got Y is a symbol, right? AZY. So this is the symbol of element. The bottom number is proton number. The top number is nuclear number. And remember one thing, if you want to get nuclear number, this is proton, number of proton plus number of neutron. This is what the meaning is it? Okay. Proton plus neutron. So for Y, right? You just write Y, and then proton number is 8, correct? I mean 6, sorry. 6. And then nuclear is 6. Nuclear is 12, sorry. Nuclear is 12. So they give you the nuclear. Also very nice. Actually, also kind of free mark. Okay. Just know the simple theory. X reacts with Y to form YX2. Compound YX2 undergoes sublimation process at negative 78 degrees Celsius. Okay. So X react with Y to form YX2. So sublimation, remember sublimation is solid straight away turn to gas. Okay. straight away turn to gas. It's called sublimation. Normally, the likes of naphthalene, acetamide, dry ice, iodine. Okay, example lah. So it means at negative 78. At negative 78, already turned to gas. Okay, so physical state, this is also another free mark. Okay, unless you don't know what is sublimation, then it's not free mark. Yeah, so it's solid to gas. State the movement of particles in Yx2 at room temperature. Chemistry, remember, always room temperature is 25 degrees Celsius. Okay, so you know, right? Yx2 at negative 78 degrees Celsius is already gas, man. So confirm 25 also gas. But they ask for the movement of particles. So we have to say, you don't say whatever. I think who told me already, how to write I forgot what is the answer. I mean the D2. Okay. So you have to say move randomly and or freely. Or you can say one of them also can. Fast cannot, fast cannot. Yeah. Better not. Okay, better not. Maybe can but a little bit risky. Okay? Or you can say just move randomly also can already. Or you just say move freely can. Okay, question one finish already. Any question? I think it's quite simple, right? So, and then question two. This is Form 4, Chapter 7. Form 4, Chapter 7. Okay, diagram 1.1 shows the apparatus setup for an experiment to study the rate of reaction between. Now, this one always come out SPM. Okay, doesn't matter with. Normally it's acid plus metal. Okay, you got 4 experiments, right? So not the most common is acid plus metal. Okay, sometimes it's acid plus metal carbonate. Yeah, the other two, the H2O2 one and the sodium bicarbonate is a bit less. Not bicarbonate, sorry, thiosulfate. Sodium thiosulfate one is a bit less. Yeah. So see, they give you this amount of hydrochloric acid and excess zinc granules. So they already give you the volume and the molarity. Volume is 10 cm cube. Molarity is 0.1 mole per m cube. You might have to use later for the calculation. But I think no. In this case, do we use it? State the volume. I think no. Okay. So for certain question, you might need to use. But in this case, no. So if you ask me about the equation, this is HCl for hydrochloric acid. Okay. Zinc granule, zinc, right? So if that's the right equation, what can they be? This is ZnCl2. And because Zn is 2 plus, Cl is minus. That's why you got ZnCl2 from these ions. And then you got hydrogen gas, H2. So normally in this case, you see what they are measuring. They are measuring the volume of hydrogen gas produced. All right. So, and then balancing times 2 for HCl. Okay, so this is the chemical equation. Okay, if they ask for ionic equation, sometimes they do ask. Okay, so the Cl minus not important. Only the acid punya H plus and the zinc will collide to each other. These two, okay, which is the H plus react with zinc to form Zn2 plus H2. if they ask. Okay, I know this question they didn't ask, but maybe future question they ask. Possible. Okay, so table 2 shows the volume of gas collected at 1 minute intervals when 1 cm cube of 0.1 mole per cube copper 2 sulfate solution. Now, if you see this is the catalyst. You know what's catalyst, right? Catalyst is to speed up the chemical reaction, right? Especially this CuS4 can apply for acid plus metal. Can speed up the reaction between acid with metal. Okay, so here they should be asked already. What is function of copper sulfate in this experiment? So yeah, you can just say as a catalyst. Can just say as catalyst. Yeah, one mark already. State the volume of gas collected when the concentration of 0.1 mole per cube copper 2 sulfate solution used in this experiment is replaced by 0.5 mole per cube copper 2 sulfate solution. Okay, so in this case, volume of gas collected. You see, so you see this experiment, what happened is, this guy, let me ask you, what is the maximum volume of hydrogen gas collected based on this table given? 18. Okay, you see, the maximum at the third minute, the volume of gas stops increasing, right? So normally the rate of reaction is between the 0 minute and the third minute only. 0 to third minute. The other two not important, useless. Okay, but unless there's a draw graph, then different. If there's a draw graph, then you have to include. Okay, you have to include. So in this case, you see, if I increase concentration from 0.1 mole per cube to 0.5 mole per cube of copper 2 sulfate, it means the increase the concentration of a catalyst. Do you think it will increase the volume of gas collected? Yes or no? No, right? Most probably not. No. Yes. Okay. The logic is, it's not about the catalyst. It's not about more gas produced, more gas collected. It's about you use shorter time to get the volume of gas. Yeah. So in a way, you can say higher rate of reaction. So yes, the answer is still 18 cm cube. Maybe some people confuse here. Okay. Some people might write 90. Okay, which is wrong. Which is wrong. Unless the question change, not copper sulfate, the question change to hydrochloric acid. Then you might have to write 90. Yes, if you increase the concentration of acid, of course, then it will affect. Okay. So we should write the exact number or just unchanged also can. No. Cannot write unchanged. Cannot. Do you know why? You have to make sometime the problem is you have to assume the examiner is dumb. Okay, dumb meaning they don't know what you know. Okay, so how does examiner know that you know is 18? No, right? Yeah, say the volume better say okay, don't say unchanged. Okay, they didn't in the sentence they didn't tell you maximum volume of gas collected is 18 cm cube. No, this is analyzed by yourself. So you can assume unchanged. Unchanged, examiner can think until here, I don't know. Okay. So yeah, 80 cm best. Best. And then C. This one asks you to draw at the same axis, sketch the curve of energy profile when copper 2 sulfate is not added in the experiment. So obviously this one is the energy profile diagram. Okay. So from time to time they ask you to sketch. So now, by the way, in case you don't know, a let me show you. Do I have the ruler? Wait. Now, this part, wait, this part, what does it call? The distance between reactant and the highest peak. This is called activation energy. Activation energy. Let's say I label EA. The answer is a little bit. Okay, EA prime has the EA prime. Activation energy. The EA prime, right, you can label as got catalyst, okay, with catalyst. Okay, with catalyst. Normally with catalyst, right, the distance. Why my iPad like? For those who late enter, miss in front, later you just watch back for question 1 and 2. Yeah, you watch the video because later I will upload. Okay, so in this case, you see the distance normally is shorter because with catalyst, normally you save more energy. Okay, save more energy means don't have to use so much energy to apply to carry out the reaction. Okay, so but they say not added means no catalyst. If there's no catalyst, okay, wait. I think this graph is a bit funny, but uh, because they ask you to draw a sketch is not added, not added. Okay, doesn't matter lah. Okay, but you just label lah. But it's best for you to label. You can assume this is with the catalyst or this is without catalyst, but doesn't matter. You label. Okay, so without catalyst means normally you have higher activation energy. Normally we will have higher activation energy. So they label. Now, label. This is EA. Now, EA is without catalyst. Dotted. Dotted lah, dotted better. One dotted, one straight line. Okay. I think sure this. Yeah, 1 mark. I know it's 1 mark, but yeah. Okay, and then donkey. If you still don't understand, right? Let me explain to you. Okay. So you see, without catalyst is like when you walk from school to home lah. Walk from school to home, then you take, then you use your leg to walk. Then you use your leg to walk. Compared to if you have catalyst, is like you have transported. So you can save your leg energy. Use shorter path to go home, shortcut to go home. Instead of just walk all the way 3 km, you can just take a grab, take a transporter. Okay, so donkey reaction between zinc and hydrochloric acid occurred when the particles of reactant collide with each other. Only effective collision will produce products. So the keyword here is effective collision. So state two conditions needed to for an effective collision to occur. So normally this part is a bit rare, okay, to find. So you know what is effective collision? Okay, it means uh I think most of you learned already the sentences that you memorize for the reaction, like 5 marks, right? Or the frequency of collision between particles, this particle and this particle, the frequency of effective collision between this particle and this particle is higher like that. Okay, so what does it mean? Frequency of collision, frequency of effective collision. So you see, let's say in this experiment, okay, I'm talking about zinc and hydrochloric acid. So you see, this is zinc. Let's say this is HCl. Okay, H plus and Cl minus. H plus and Cl minus. So what happens is, okay, see, this is the result. So when this particle, let's say trying to collide, they try to react with zinc, right? HCl try to react with zinc. So when they react with zinc, they have to collide correctly. Let's say example, if Zn collide with H plus, let it collide, will they have reaction? Zn and H plus, yes, right? Because if Zn react with the acid, Zn can dissolve into acid. Dissolve into acid, then become Zn2 plus and the H2. Then the hydrogen, then it means H plus will turn to H2, correct? If you hit like this, then it become H plus. I mean, become H2. But if I use another way around, another direction to hit, like this. Now, like when you hit like this, right, the H plus cannot reach the Zn. So it means in this case, it's not an effective collision. It's a collision, but it's not effective one because you don't get the product that you want, which is hydrogen gas. You don't achieve your goal. Okay, so this is called effective. Effective means efficiency, have high efficiency, to really achieve the thing they want, to get the thing they want. Okay, that's why you got collision and effective collision. Collision means just normal collide lah. This way, this way, this way, or doesn't matter which timing, doesn't matter which direction, doesn't matter if the particle have energy or not. Okay, but in this case, you must have energy to collide, and also with the correct direction, we call it correct orientation. So the first condition is correct orientation. It's like a correct direction, correct timing that for the particle to collect. Second, second is what? Achieve. Now, for particle to react, you see this graph, right? Even this graph explained to you. Okay, for the reactant to react, the reactant must have least equal to the activation energy, equal or more than the activation energy. Then only the reactant can collide to each other. So the particles, okay, I think I should write better like this. Correct orientation, achieve equal or more than activation energy. Yep. Okay. Any question? For those miss in front, later I send answer and also the video. Okay. Any question with this question? Okay, move on. Question 3. Diagram 2 shows the flow chart for the reaction starting with element Y. Element Y is located, this one is form 4, chapter 4. Okay, located in group 1 of the periodic table. So you got Y react with oxygen to form oxide Y. So group 1, right? Remember group 1 got what elements? What elements can you think of? Like lithium, like sodium, like magnesium, like potassium, correct? And what is the chemical reactions? What is the chemical properties? I mean, who is more reactive? Most reactive? Potassium. Who is least reactive? In this case, lithium. And can react with who? Got 3, right? Chemical reactions. One can react with water, can dissolve in water. Number 2, can burn with oxygen gas. Number 3, can burn with chlorine gas. So as you can see, this one react with oxygen, right? Y plus O2 become Y2O in this case. Then after that, I take this Y2O, dissolve in water, become YOH. So you know how to write the equation? No, no. Yes, no. Let's say I show you. Okay. So let's say I show you. You assume you might not understand. Sometimes people cannot understand what is Y. How do I start with Y? Okay. You can remember. Let's say you assume Y is one of them, one of the elements. Let's say I assume sodium. Okay. So sodium burn with O2, you will get what? Na is what charge? One, right? Because it's group one. Group one means donate 1 electron. Yes. So you get Na plus. And then O is what charge? O2 minus. Yes. O2 minus. O2 minus. So what is the formula? The 2 we give to Na. So Na2. Then 1O. Some people still make this mistake in writing the equation. Okay. So then the balancing equation. So you got 2O at the left, 1O at the right. So multiply 2 for the whole thing. Now how many sodium total? 2 times 2, 4. So sodium here times 4. So we can apply this to B actually. So since they asked you to write equation in reaction 1, right? So you can apply it. I can change the sodium to Y, right? So it means Y plus O2 become Y2O. Oxide Y means Y2O, right? Oxide Y means Y2O. Okay? Yeah. So, and then balance equation same thing lah. 2Y2O because you got 2 oxygen at the left. Now you got 4Y times 4 for the front Y. Then you got 2 marks after balancing. Okay? Yeah. And then I also can show you the reaction two. Okay. Reaction two, they are talking about same thing. I try to dissolve sodium oxide into water to get sodium hydroxide. Sodium hydroxide. Okay. Which here you got two Na, 2H. That's why I multiply 2 for NaOH. If I want to write for the Y, same thing. Y2O react with H2O become YOH. In this question, normally you write Y because you assume you don't know what is Y. Which in this case, they didn't tell you also, right? So yeah. And they ask the number of valence electron in group 1 elements. This is another framework. Okay. So lithium 2.1, sodium 281, potassium 2881. So all of them have how many valence electron? One. Okay. One. Even you can feel my iPad like it. You can feel it, you can feel it. Every question like this. Oh. Okay, you dream in your dream. Okay, so 0.5 mole of element Y is burned in oxygen as shown in reaction 1. Calculate the mass of Y oxide formed. So the information is 0.5 mole of element Y. Find the mass of Y oxide. Hey, this one important the equation I bring the equation. I bring the equation See, and then ratio mass, two steps only, 2 marks. So see, just write down the information. If for those who always confuse this question, write down the information they give 0.5 mole of LMY. Okay, 0.5 mole. And then mass of Y oxide. This is Y oxide, right? So you write down. Since you want to find mass of Y2O, then you write mass equals to question mark. So, and then what you do? Now, you already got number of mole. This question is so easy. Okay, for number of mole for the Y, so you can just straight away do ratio. Okay, ratio is 4 mole of Y to 2 mole of Y2O in this from the chemical equation. So I can straight away say 4 mole Y, 4 mole of Y, okay, produced. I write full sentence in this case, since the answer scheme shows full sentence. 2 mole of Y2O, and then it means you have to divide by 2 lah. Okay. So if 0.5 mole of Y2, I mean Y, then produced 0.5 divided by 2, because 4 divided by 2, you get 2. So 0.5 divided by 2, you get 0.25 mole of Y2O. Then you take this mole to find mass. Because what is the formula? Number of mole equals to mass over molar mass. Basic form 4 chapter 3. So if you want to find mass means number of mole multiply molar mass. So mole is 0.25 multiply. Hey, they give you right? Molar mass of oxide Y 62. I'm sorry, it's so simple. 15.5 gram, am I right? So number of mole can be any objective structure, right? So make sure you know the basic thing. Don't escape. Okay, there's no escape for this calculation. No escape. I know someone does that, but yeah, please no. It means this in at this point you still don't know how to calculate this, then I don't know what to say. Okay. So yeah. And then predict the pH value of YOH solution formed. Yeah, Mr. Your friend, right? So in this case, pH value of YOH. YOH is what? What chemical substance? What kind of chemical substance? Alkaline. Okay. So you know lah. Group 1 actually is called alkaline metal. Alkaline metal. When you dissolve this alkaline metal into solution, into water, it can show its alkaline properties, right? Like example, YOH, it can show inside got OH minus. And just in case you don't know, okay, all these lithium, sodium, potassium, they are strong alkaline. Okay, like last metal with lithium hydroxide, sodium hydroxide, potassium hydroxide, LiOH or KOH or uh, NaOH. Okay, but in case okay, you don't know, right? Some people, if they are intelligent enough, they can use this to find what is the element for Y lah. Okay, so actually Y is sodium in this case. Y is sodium. Yeah, so because you can imagine Y2O, right? It means 2Y plus 16 equals to 62. 2Y equals to 46. Y equals to 23. RAM with 23 is sodium. Okay, so sodium hydroxide means very strong acid. Strong alkaline. If it's strong alkaline, YOH, normally strong alkaline, the pH is between 12 to 14. Yeah, 12 to 14. Weak alkaline is 8 to 11. Okay, like 11 is ammonia. So it's best if you write pH 14. pH 13, 12, 13, 14 accepted. It can be 12, it can be 13, it can be 14. Cannot 8, 9, cannot. No. Yeah. Now, unless it's ammonia, then you write 11 or 8 or 10. Okay, done? Okay, question 4. This one is Form 4, Chapter 5. Form 4, Chapter 5. Okay, so Form Chapter 5. I think this question also quite simple. Okay, like mixed with the number of mole calculation also. So sodium atom and chlorine atom is shown below the standard representations. Okay, write the chemical formula for chlorine molecule. Okay, so in this case, it's quite free mark. Okay, molecule means like this. Okay, which is Cl2. This is chlorine atom. One is chlorine atom. The two is chlorine molecule. The whole thing is one molecule. Okay, another free mark. All right, basic formula. Sodium reacts with chlorine to form compound Q. See the type of bond in compound Q. Okay, this one classic. Okay, so you know right? Okay, based on this, normally, if you want to know what kind of compound form, what kind of bond form, you can check the electron arrangement. So sodium, what is the electron arrangement? If the proton number is 11, 2, 8, 1, chlorine is 2, 8, 7. So metal, normally 1, 2, 3 valence electron metal, right? Non-metal is like 4, 5, 6, 7. I mean for ionic is 5, 6, 7. So yes, this one is metal react with non-metal. Normally, Na will donate 1 electron, become Na plus. Cl will receive 1 electron, become Cl minus. Right? Basic, right? So what kind of compound? When the Na plus will attract the Cl minus, is ionic. Not bond, you right? Because they ask for com. What? Is it bond or compound? Oh, bond. Okay, bond is ionic. So ionic bond. Okay, ionic bond. How is the bond in 4B1 form? Okay, so how does this bond form? Sodium will transfer the electron to chlorine. We call it transferring of electron. Transferring of electron. Transferring is like the whole thing, whole general thing. Then under transferring means metal donates electron, non-metal receive electron. Right, the chemical equation for the formation of compound Q, another equation. So many students just like this. Na plus Cl, NaCl. Okay, then you hope you are correct. So of course you get 0 mark in this case. Okay, so you have to remember sodium is single, yes. Chlorine is not single. Just only written chlorine exists as molecule. So normally you write Na plus Cl2. Then normally if people forget this two, this is the common mistake. Na plus Cl2, then you get your kitchen salt, which is just now I told you, right? NaCl. Because the charge is Na plus and Cl minus. If you leave it like this, of course, another 0 mark, because you have a balance. Okay, so left side Cl got 2, multiply 2 for this Cl. This Na got 2 now, times 2 for the front Na. And now you get 2 marks. Is that clear? And then you have to use this another calculation for number of mole. Okay, so they ask 2.3 gram of sodium. Okay, you have to use the equation. 2.3 gram of sodium react with excess chlorine. We don't care about the excess, okay, about the information for excess. We care about the real value given, 2.3 gram of sodium, the Na. Ask you to find mass of compound Q. So you got 3 steps, 3 marks, 3 steps. Okay. So first step, okay, before first step, write down the information first. Na 2.3 gram. Mass of compound Q, this compound Q, NaCl. Okay, so mass equals to question mark. So it's another calculation, same thing, right? So you have to apply then the number of the formula, number of moles equals to mass over molar mass. I see this one already in twice in the question, right? So in this case, yes, first step, no need to write one, so number of mole of Na, mass is 2.3 gram, one N is 23. Okay, you can probably find this in periodic table. Okay, normally exam will give. Okay, unfortunately, I know I didn't print for you lah. Okay, so but you can find out from the previous papers. Okay, that I print. So inside contain 23 lah, sodium 23. So it means if exam didn't give, then you have to find from the periodic table. For those who don't know, periodic table, right? You see element with two different numbers, right? Or you see something like this. So the molar mass always the bigger number, or call it nuclear number, the RAM, the relative atomic mass. The smaller number is proton number. Smaller number is proton number. Okay, so you get 0.1 mole, and then actually this paper is not that hard, right? I feel. Okay, so in this case, then you got ratio, mole ratio. Okay, 2 mark only. Literally 2 mark, man. Okay, so it means the ratio same, right? But in case like you choose right now, okay, or 2 mole of Na produce 2 mole of NaCl. That's why 0.1 also same lah. Ratio of sodium to sodium chloride, 2 to 2, then you also get 0.1 for each. Then if you want to find the mass of sodium chloride, use number of mole multiply molar mass. So in this case, mass of NaCl equals to number of moles 0.1 multiply. And you can find for the periodic table again. One Na is 23, one Cl is 35.5. Normally they also give 35.5. Normally paper one, I think they didn't give the periodic table. That's why normally they tell you RAM equals so much. Paper two they have to use your own. Sometimes you have to use your own periodic table to find out. So in this case, it's 5.85 gram. Am I right? So far, okay. So far, so good. Okay. Okay. Question 5. This is Form 4, Chapter 6. Okay. So, diagram for 1 shows an apparatus setup to determine the endpoint of titration between hydrochloric acid and potassium hydroxide solution using phenolphthalein as an indicator. Okay, so you got HCl, which is 0.5 mole per meter cube. You also got potassium hydroxide solution. Okay, so which is KOH plus the phenolphthalein. So at this point, you already know, right? You did this experiment. If you put phenolphthalein, which is originally colorless, phenolphthalein is colorless. But if you add into alkali, then you will get pink color, right? This one basic. Okay. And then state the meaning of acid. Okay, so this is another one. So in this case, uh, I just start down. My iPad so laggy. Wait. Give me a second. Okay, literally cannot move to the one. Okay, so you can say chemical substance, chemical substance that ionizes. Some I know some school say dissociates. Also can same meaning. Ionizes and dissociate the same. But normally ionizes a bit easier. Okay, ionizes in water to produce what ion? Acid, hydrogen
Hydrogen.
ion. Or you can write produce H plus. Equation. Another two free 2 marks. Okay. Another free 2 marks. Your friend, I think your friend will be zero. I mean he will empty. Okay. So in this case, okay. Write the chemical equation. He won't write anything. So write the chemical equation for the reaction. So you don't believe? You ask here, okay? You cannot answer one bit. So yeah, in this case, and it chose to be like that, okay? So nothing I can do. So in this case, write the chemical equation for the reaction. So HCl
KOH.
plus KOH. What do you get? For those who still don't know,
Plus H2O.
H plus you got OH minus, check with OH minus, K plus attract Cl minus. So basically, you get KCl
Plus
and
H.
H2O. This is very straightforward. Acid react with base, you get salt and water. 2 marks, okay? Don't even have to balance because it's already balanced for you. Okay. Yeah. Calculate the volume of acid needed to neutralize the potassium hydroxide solution. Okay. So in this case, I know the answer scheme looks weird. Looks weird. So in this case, I think I've sent it later. I have to adjust a bit. So the answer scheme a bit funny. I don't know why, but yeah. Now normally you can use MAVA over MBVB equals A over B lah. Okay, I'll show you two methods. Okay, but I would say the other method is safer to get more marks. I don't know why, but apparently the answer scheme is very funny. Okay. So I don't know why, no what reason. Okay. So normally for neutralization formula. All right. Normally I try the first method first. Okay. Normally the first thing is MAVA over MBVB equals to A over B. This is what happened, right? Yeah, this is what happened. And then you know as M, right? M is the molarity, or you call it the concentration. Okay? Now this is a given, oh, 0.5. This is the M lah. Now this is MA. 0.5 is MA molarity of acid. Another 0.5. This is for alkali. MB molarity of base. Volume of base given. So what do they ask? Volume of acid. VA equals to how much? So yes, another one that you have to use calculation. The equation. Yes, you also have to use label of equation. The information of equation. Okay. So in this case, let's sub inside. MA is 0.5. VA don't know. MB is also 0.5. VB is 25. Now you must ask, then what is A over B? A over B based on the equation, the number of mole for the equation. What is the number of mole? One, 1. Didn't write means 1, not 0. Okay. So that's why you get 1 over 1. 1 over 1. Then you find VA lah. VA means okay, cross multiply. Basic mathematics, you know, right? Cross multiply. So it means 1 times 0.5 times VA equals to 1 times 0.25 times 25. Actually, or you can say VA is like this, divide by 1 times 0.5. Cross multiply, cross multiply. Then you make VA as a subject. So you get 25 cm cube. 25 cm cube. So apparently the answer scheme is a bit funny. Okay. Sometimes they tell you this only 1 mark, 2 mark, I don't know. Okay. So if you're scared to be more safer, then you use classic number of mole to find. Number of mole ratio volume. I think sometime lah, the school will give you more mark for this. I don't know why. What's the reason? But it is what it is. Okay. So even as scheme is a bit funny. Suddenly find number of more for no reason. Okay. So I mean later I can show you. So in this case, that's why number one is just straight away to find number of mole. Now you know, right? Number of mole formula is MV over 1000. Yeah. When they give the concentration and the volume, right? So yeah. So you see, KOH has the more complete information. So normally, of course, you start with KOH, right? So KOH. Then what you do? You just straight away use 0.5 multiply 25 over 1000. Then you will get 0.025 more. Eh? No, you will get 0.0125 more. It is right. Then you do ratio lah. Then you write the ratio. Ratio from KOH to HCl. Right? Or 1 mole of KOH to 1 mole of HCl. That's why if I got 0.0125 mole KOH, I will also get 0.0125 mole HCl. And then I use this mole to find the volume of acid. So number of mole of HCl equals MV of 1000. So you try to make V as a subject. So volume of HCl is mole. Mole symbol is N. N. Yeah. N multiply 1000. Move 1000 to the other side. If N move to the other side, become divide. So divide by molarity. So mole is 0.0125 multiply 1000 over molarity is molarity is 0.5. Let me find. Okay, you get 25 cm cube also. See, yeah, you got two ways to do it. Okay, I say the safer one to get more marks is one, especially if they here got 3 marks sometime, then better you use this one. Because sometimes according to the school teacher, they will give you full mark if you do this. They don't count for the mark for ratio. Okay, this is what I heard lah, what I heard. Yeah. Yeah. The experiment is repeated by replacing hydrochloric acid, okay, with acid P. It was found that the volume of acid P needed to neutralize potassium hydroxide solution is half of the volume of hydrochloric acid used. Identify acid P. Okay, so in this case, you see, HCl, just now is HCl plus KOH, react with, react with KOH to form KCl and H2O. So in this case, just now, the volume of acid needed is 25 cm cube. You calculated, right? But they change with acid P. If they use acid P, volume of acid P needed half of the volume of HCl. Okay, half of the volume of HCl, which is you get 12.5. Acid P only needs 12.5 cm cube to neutralize the 25 cm cube of KOH. So what is acid P? What is acid P? Yes, that's one correct answer. So yeah, the answer is sulfuric acid. Very good. Sulfuric acid. Right? Diprotic acid, remember? Okay, H2O4 is diprotic acid. Okay. When ionizes in water to produce 2 mole of hydrogen ions. So the simple look at this, like HCl, right? Only produce 1 mole of H plus in this when you ionize in water. So in this case, it means if you got, let's say if you got 1 cm cube of HCl, only produce 1 mole of H plus. That's why you need to have 25 cm cube of HCl to produce 25 mole of H plus. Okay, but it is for H2S4, 1 cm cube, you will get 2 mole of H plus. So in order for the H2S4 to produce 25 mole of H plus, it only needs 12.5 cm cube to do that. So this is the explanation. Basically means the number of mole of hydrogen ion is double. Okay, double the concentration. Okay. Any question? Okay.
Sure.
Ah,
I don't understand the last two chemical equations. I don't understand I don't understand
which one?
like uh anything to yeah,
What do you mean which one?
the HCl part plus KOH. I understand the chemical equation, just that I don't know how I don't understand it because I don't understand the key.
You mean this one? The calculation or the equation or the
The
H2S one?
four.
This one.
Yeah, for four.
The sulfuric acid. Don't understand why sulfuric acid.
Uh, it is H2 acid.
Oh, simple. Okay. Just remember this. The more the H plus produced, the more the concentrated for the acid, the higher the concentration of the acid. Which also means in this case, means you see, this is the expression. You see, hydrochloric acid is monoprotic acid. If I got only one acid molecule, I only produce one H plus. Let's say if I require 25 H plus to neutralize the alkali, I need to have 25 cm3 of HCl. But in this case, no need. H2S4, you only need lesser amount, lesser volume in order to produce the same amount of H plus. It's because very thick, because very concentrated, double concentration of HCl. Understand? That's why the volume required for acid P is half. Because you need only a little acid in order to neutralize the alkali. Yeah. Actually, both acids are strong. It's just that this one is H2S4 is 2 times stronger. Okay. Diagram 4b, diagram 4.2 shows the apparatus setup in experiment to study the acidic properties of oxalic acid. Okay. So, explain the difference in the observation between experiment 1 and 2. So, this is the quite an easy question. Okay, easy to get one. So, you see, one added water. This one is 6.1. The role of the water, or you can say importance of water for acid to show its acidic properties. Okay, when they add water, into the oxalic acid, okay, then inside you get H plus. If it is propanol, the acid remains neutral, no charge. Okay, propanol is an organic solvent, it's not water. Water only when acid in water, they only can ionize. Okay, so they also told you that blue litmus paper turns red. For the first one, the second one, the litmus paper doesn't change. Some people told me, can I write for the observation? Can I write difference? The observation can I write blue litmus paper turn red? Cannot. Not say cannot, but if you write nothing happen. It's quite useless because they already give you. It means you're just copying back the thing. You won't get mark. Okay. So in this case, what I can say is say the things that not in the table. Okay. Explain. So what can you say? Okay. In experiment 1, okay, oxalic acid shows its acidic property. Is that this one mark already? One mark already. Show acidic properties. Or you can say, okay, or you can say oxalic acid ionizes. Normally you say this one, right? Ionizes in water to produce hydrogen ion. Like that also can. This one I normally say, right? And then in experiment 2, oxalic acid does not show its acidic property. 2 mark already. Like that. Or you can say oxalic acid does not ionizes in propanol. Hydrogen ion is not produced. Là lớp. You are just holding a second. Nothing more. Too much. Basically, just remember, doesn't matter with acid or with alkaline. Acid needs water to produce H plus. Alkaline needs water to produce OH minus hydroxide ion. That's it. But this case is talking about acid. Okay. Oxalic acid produce carbon dioxide. If reacts with metal carbonate, yes. So addiction. Done. Next. Question 6. This is Form 4, Chapter 3. The empirical one. The meaning of empirical formula, right? So Form 4, Chapter 3. Okay. Table 3 shows the word equations for two reactions involving metal X and metal oxide Y. The empirical formula of X oxide and Y oxide are determined through method 1 and method 2. So first one, X react with oxygen to form X oxide. Second, hydrogen react with Y oxide to form Y plus water. So this one is a very basic question. Okay, it's very easy one, nice one. Okay, so remember the experiment react with oxygen one. Got a crucible one. Okay, then you heat the crucible. Okay, with the lid covering. Right, inside got magnesium. Inside got magnesium. Okay, then you have to let oxygen to enter. Right, so normally it's magnesium, zinc, or aluminum. Right, normally it's magnesium. Yeah, to measure the mass, yes, before and after, right? Before is magnesium, after you get magnesium oxide. Okay, so it means this equation is Mg plus O2, you get MgO, example. Or in this case, it's X. You can also kind of X plus O2, you get XO. Same thing. Okay. So the second one, remember this out, right? The second one set out is like this. Remember this one? In the middle got CuO, remember? One you got water, one side water, one side you got zinc with HCl to produce the hydrogen gas. Right? You got two examples, right? Learn from Chapter 3. Okay. So this one is the CuO react with hydrogen gas to get copper and water. Or in this case, YO react with hydrogen gas to produce Y plus H2O. Doesn't matter. Okay. So you got two experiments. What is meant by empirical formula? Okay. Again, lagi. Okay, so
Simplest whole number ratio.
can start with chemical formula. You know, right? Chemistry have to write whole thing, right? Okay, so chemical formula that shows the simplest ratio number of atoms, okay, in each element, okay, of a compound. Yeah, the full one. Normally meaning, right? If your brain cannot take it, right, no memorize. Do the other thing first. Yeah. But this meaning, but for some meaning, popular meaning, you should be in your head, lah. Okay. Like empirical formula, Rosen number, nuclear number, redox reaction, some basic formula. Meaning of soap, yes, popular. Yeah. Suggest metal X and metal Y. Explain why you choose the metal. Yeah. So X, very simple. Magnesium. Accept magnesium, they accept zinc, they accept aluminum. Okay. Why? Now, why it cannot be copper? Why it cannot be lead? Why it cannot be lead plus O2? Why cannot be copper plus O2? What's the problem? Yeah, you can say lah. Okay, because in this case, uh, wait magnesium is more reactive towards oxygen gas. I know answer scheme sometimes a little bit questionable answers. Okay, but I think this is the best answer. Metal Y. Metal Y is copper. Reason? Why is not magnesium? Why is not magnesium react with hydrogen gas? I mean, why is not magnesium oxide react with hydrogen gas? Yeah, because in the electrochemical series, magnesium is more reactive than hydrogen gas. Magnesium cannot, I mean, hydrogen cannot displace magnesium. Okay, so we can say, uh, or the reason is you choose copper because copper is below hydrogen. So copper is less reactive towards, I mean, less reactive than hydrogen gas. Okay, less reactive than hydrogen. Yeah. So that, you see, so that copper is less reactive than hydrogen, so that hydrogen can run past the O away, become CO, become H2O. But this one cannot. This one got result. Magnesium oxide plus H2, no result. Okay? This one. Ask you to find empirical formula. It means you have to draw the table, right? It means to draw a table. Wait, wait. Okay, that's 1, 2, 3, 4. Yeah, let me take time to draw. Okay, now this. Okay, and then cái là sao? Okay, then you label. Okay, element, mass, number of mole. By the way, the mass unit is gram. Number of mole, the unit is mole. Okay, ratio of mole. Empirical formula. Okay, empirical formula just in one column, much in one column. Okay, then we can do that. X oxide. So XO. X is 1.08 gram, as you can see. 1.08. O is not 0.96. O is 0.96. And then number of mole, mass over, remember, same thing, mass over molar mass. So 1.08 divided by 27. Yeah, they give you x 27. You will get 0.04. O is 0.96 divided by 16. You will get 0.06. Then remember what you do? What do you do? Divide the smallest number. So you see that 0.04 is smaller than 0.06. So both divide by 0.04. So you get 1.5 for the O. 1.5, this it means you have to get one more column. Okay. Simplest mode. Okay, simplest mode is you change the decimal place. I mean, you change decimal place to whole number by multiplying 2. Because normally 0.5 you can multiply 2 to eliminate the decimal. So you get 3. If right side multiply 2, left side also multiply 2, then the final formula is x2O3. X2O3. Which method is suitable to be used to determine the empirical formula for lead oxide? Okay, I write for you lah. Okay, in case you still don't know which one is which one. Based on the reactivity of metal, Okay, please stop calling me a careless zebra. This one, right? So normally three is too reactive. Normally you don't put K and A and Ca. Then normally magnesium, aluminum, and zinc. Normally burn with oxygen gas. Normally these four, actually these five start from iron. Okay, start from iron. Normally you use iron 2 oxide, tin 2 oxide, lead 2 oxide, copper 2 oxide, silver oxide. All these burn with hydrogen gas for the second experiment. So which method for lead oxide? The PBO method 2, the hydrogen one. Okay. Done. Okay. Next question 7. This one is Form 5 chapter 5. Now I know you haven't learned Form 5 chapter 5. Okay. I know you haven't learned. But don't worry. Okay, don't worry. Um, what I can do is you just listen. Okay, because I have to post this to YouTube. Okay. Later if you learn this chapter already, then you look back. Okay, look back the answer. Okay. So 4 chapter 5 is about this one. This part is about the soap and detergent. Okay. The process of producing soap and detergent. Okay. So I can teach you first. Okay. So you got the idea first. So cleaning agent A. Okay. Now, if you see, doesn't matter with detergent or soap. Okay, actually you got two parts. Okay, you got two parts. So what happens is the first part, see, normally this is called the head, or in biology you learn this is called hydrophilic head. Okay, so it means this part likes water. Okay, then at the back part, actually it's like covalent instead. So we call it hydrophobic tail, right? So they don't like water. They like grease. They like organic solvent. They like oil. Okay, they like dirt. So this part is the head of soap. This part is the tail of soap. I mean, this one is not soap. This one is detergent. Sorry. Okay, the same thing. The structure of soap. Okay, this part is the head, which got charged one. This part is the tail of your soap. Okay. Normally, how do we recognize which one is soap, which one is detergent? So you see, the similarities both got sodium ion. Okay. But the differences is for detergent, normally you got OSO3 negative. OSO3 negative. Okay. So OSO3, this part means the first one is detergent. If you see, okay, this is OSO3, OSO3. Okay. If you see COO, then is soup. That is soup. Yeah. Produce soup. What do you have to add? Okay. So in this case, you have to add sodium. Eh, yeah, you have to add, right, you have to add sodium hydroxide. Okay. Then you have to add You use fat, this one is fat. Structural formula of fat, or you call it oil in liquid form. In solid form is fat, in liquid form is oil. Okay. Which you learn okay, in biology, probably learn like saturated fat and unsaturated fat, right? So if you use fat, add alkaline, then you get glycerol and soup. Yeah, this is the part for glycerol. In biology, this is called the triglyceride. Okay. Yeah, this part, the fat, the fat part is called triglyceride. But anyway, not important. Okay. So in this case, the detergent for A, right? Detergent needs two processes to produce. One is added acid, added sulfuric acid. Added sulfuric acid is called sulfonation or sulfation. Same thing. Okay, you add sulfuric acid into long chain alcohol. Okay, this is a long chain alcohol. React with H2S4, then you get this. This is the sodium. Sodium. This is the acid actually. One kind of acid. Okay, one kind of acid. You got H plus here. Okay, so you got H plus, which is an acid. Okay, so then the acid also react with Cr, same thing, right? React with substance Q and AOH. That's why you got Na plus in the end. Okay, and add NaOH is called neutralization when you add alkaline into acid. So to produce detergent, got two processes: sulfonation and sulfation. Okay, and neutralization to produce soap is called saponification. Saponification. Okay. Meaning of soap. So it's really very short, very short. Actually, it's quite short. Okay. You add NaOH into fat, isn't it? So what can you say? Basically, you got sodium or potassium salts of fatty acids. Sodium or potassium salts of fatty acids. Name the Say the name of substance Q. I mean, okay, you must ask what is sodium and potassium. It means you can add either NaOH or KOH. Same thing. Okay. Normally, if you add sodium hydroxide, you will form solid soup. If you add potassium hydroxide, normally you get liquid soup. Okay, but not so important. Okay. State the name of substance Q. Sodium hydroxide solution. And you can just say sodium hydroxide NaOH. Ahmad Ahmad participated in a campaign at the beach in Tanjung Bidara. His shirt was stained with mud and he washed his shirt with a type of cleaning agent. It was found that the mud stain on his shirt remained. Okay. So he said he washed his shirt with a type of cleaning agent, but the dirt cannot wash off. Mud stain is still there. Suggest cleaning agent A or cleaning agent B, which is more suitable to remove the stain. Give your reason. Okay. So in this case, he probably washed his clothes at around like in sea whatever. Okay, like mineral water. So in this case, who is more effective? Of course, you use detergent. A is detergent, is it? A is detergent. So of course you use detergent to best because uh very simple reason. When you wash, when you use soap to wash in hot water, in like acidic water, hot water, mineral water, cannot wash off. because it will form scum. It will form like white color precipitate. Okay. So yeah, you can just say here got 3 marks. Okay. So you can say first part is you choose. Okay, cleaning agent A 1 mark. Reason you choose cleaning agent A. Okay. Sorry why the one so laggy? Okay, so in this case, A, because you can say salt, sea water. This guy is sea, is it? Sea water contains. Now, if you talk about hard water, right, the reason you cannot use soap to wash because you got hard water. Hard water contains these two ions. These two ions blocking you from washing. Mineral water normally contain calcium ion, the Ca2 plus, calcium ion, and magnesium ion. Okay, so but for the detergent can wash because the the soap, right? I mean the N ion, right? The N ion of the soap can react with the calcium ion or magnesium ion to form a soluble salt. Then you won't get scum. Okay, so you can say when cleaning agent A reacts with calcium ion and magnesium ion, just say no, the keyword just no scum is formed. Yeah, 3 months. First mark, choose the suitable agent. Second mark, talk about the seawater contain what ion. I mean, you can say hard water, same thing. Then the third point, no scum is formed. Okay, B1, Mr. M is a patient who suffers from thought disorder such as hearing voices and seeing things that are not real. Okay, so this one is form 5, section 5 also. This one 5.4, which is related to modern medicine. Okay, so this guy got thought disorder. It's like a hallucination, depression like that. Okay, keep hearing things. Okay, hearing voices, seeing things that are not real. Okay, I've seen people in real life have this. Okay, so yeah, suggest one type of modern medicine. An example to treat Mr. M problem, how medicine can reduce the problem that he faces. Okay, so what can you say? You can either say psychotic, okay, say anti-psychotic medicine. So you can say psychotic medicine. Then example is, you got many example. Haloperidol. This one is a bit factual. Okay. Haloperidol. I can say clozapine also can. Yeah. A lot of example. Haloperidol. Antidepressant. Antidepressant or clozapine. Okay. Okay. Or you can say barbiturates or tranquilizers also can. Many examples, you just choose one. All accept. Okay. How do we cure? Just say lah. Just reduce the whatever he got lah. Okay. This kind of disease is like depression lah. Seeing things, right? Reduce, we call it hallucination, delusion, also kind of, right? Delusion or extreme emotional changes. Yeah, sometimes people suddenly angry, suddenly very sad, suddenly crying. Okay, suddenly want to die. Yeah, extreme emotional changes. I can just say any of these. A lot, actually, a lot of answer. 3 marks. You see, okay. Yeah. Another part also about medicine, okay, but they ask cough can be reduced by using traditional remedies, okay, such as uh, tamarind juice or modern medicine such as codeine. Justify the uses of these two medicines. Normally, if you see justify means you can choose either of these. Yeah, you can choose either of these. Okay, so codeine, you know, right? Ubat batuk. Okay, normally very sweet one. Very sweet one. Okay, tamarind juice is more like a traditional medicine. Okay, people sometimes believe that ginger, this kind of thing, right? Can ginger can make sure you stay warm, keep warm, right? This kind of thing. Can see God, what God. Yeah. So justify, or you know, like what is it called already? I suddenly forgot. Okay. So a lot of traditional medicines, like Assam Jawa, is it Assam Jawa or something? Am I right or not? Aloe vera is one example, right? All these are traditional medicines. Justify the use. So I write either one. You can write either this. Okay, you can choose codeine. Why you choose codeine? Okay, you can just say better lah because codeine they are more effective. The doctor tell you oh you eat this one eat this amount. Oh, if you eat finish then can already. Okay, they won't give you too much, too little. So, but because sometimes if you just apply traditional medicine on your own, uh, you don't know what is the suitable amount, or you don't know whether this medicine is right or not. Okay, so yeah, so more effective. I can say quick recovery. If you choose, if you choose tamarind juice, and then now the good thing for traditional medicine is it won't cause any side effects. Yeah, because they don't add any chemicals, right? So it's a bit safer in the way. So does not use additional chemical. Okay. Does not use additional chemical. That's why sometimes people trust traditional medicine. In Chinese call it 中药. Okay. Yeah. Or you can also say no side effect. Also possible. Yeah, you choose either one. Justify normally you can choose either modern or traditional. Depend on what you like. Depend you want to be more traditional guy or modern guy. Okay. Yeah. Depends. Normally, I think normally you trust modern medicine. Right? I think so. I don't know. Depends. There are still a lot of people don't trust Western medicine, right? Yeah. And if I do one more, then I take a break for you. Okay. Or if you want to take a break now, okay. I'm not doing this every week because you die, I do this every week. Yeah. You do, but you take a break. Okay, for next week. Okay. Question 8. This one is from 4 chapter 8. Okay, about alloy. So, diagram 5 shows two types of substances that are frequently used in the construction of high-rise building. Okay, so define A, only pure iron metal. Okay, B, got iron plus X to make B. What is X? Yes, X is carbon, which contain like 1 or 2%. Iron contain 98%. Okay. So then to make what? What is alloy B? B is an alloy, is it? What alloy? Iron plus carbon to get steel. Very good. You get steel. Remember the six alloys. Okay. So yeah, then second, in the construction of high-rise buildings, substance B is used more in construction industry. Give a reason. Why you cannot use A? Why use B? B have what? Okay. You can just say that B overall is stronger, harder, this kind of thing lah. Okay. So yeah, strong, harder. Okay, you just even lah. You just say either one, or right? Alloy when you hit, okay, what happens? It won't change shape. Okay, which is called malleable. Malleable. It won't change shape. It won't change length. If it is normal, like normal metal, if you hit too hard, it will just become dead. If you hit too hard, okay, hit too hard, the whole thing becomes like this. Okay, become dented. That is called we call not malleable. Okay, if this one, if you hit very hard, the shape remains like this, no change. So it means you can hit very hard, also nothing change. Tahan lah. Okay. So yeah, and then a jetty pillar was hit by a ferry and caused it to break. As an engineer, choose one of the substances in diagram 5 and what should be done with the substance to strengthen the jetty pillar. Give your reason. Okay. So it means most probably, let's say this is a pillar. I don't know, a lot of pillar. Okay. Then suddenly the ship, the jetty, like this, okay. Example. So this ship suddenly just hit, boom, okay, boom. Okay, then the whole thing destroy. The whole thing break lah. Okay, started to break like this. Okay, started to break. So, how do you make it stronger? What should we do? Choose one substance, Choose one substance, 1 mark. What should be done with the substance to strengthen? 1 mark. And another one, give your reason. So total 3 marks. So what should we say? What substance do we choose? Do we choose iron, pure iron or steel? Of course, you choose steel lah. I told you, right? It's stronger, right? So can tahan. So the answer is, wait, let me, this thing every time is lag. Okay, I don't know why. Okay, so the answer is substance B. Why substance B? I mean, what do we do about it? About substance B? You mix substance B with and what does pillar made of? What material? What material? concrete. Okay, you know concrete? You know what's concrete? Inside contain like sand, like cement, like stone, this kind of thing, right? So in this case, it means you have to make one concrete. Then you make the concrete, then you add the steel bar. B is steel, right? You add steel inside the concrete. We call it reinforced concrete. You done in composite material. Okay, 8.4. So mix substance B with cement, or you can say, I think better way to say, uh, add substance B into the mixture of cement, stones, and sand. It means you're talking about you add steel into the concrete to form reinforced concrete. Now reinforced concrete got have high compression strength, high stretching strength, and resistant to corrosion. Now, if it's just steel, it's still possible to corrode. So that's why if you put steel inside the concrete, then the steel also won't rust. Okay, so you can say resistance to corrosion. So now you might ask me, what is this? Okay, so actually, okay, let me explain to you. So at the beginning, concrete concrete only got high compression strength. Okay, and also resistance to corrosion. Right? So when you add concrete with steel bar, because steel bar has high stretching strength. Okay, so if you combo these two together, then the pillar is so strong that cannot be that is unbreakable, almost unbreakable. Okay, so you add concrete with steel bar, then you will get the whole thing is reinforced concrete, which is the one of the composite material. This reinforced concrete contain all these three characteristics. Okay. So any question? Concrete made by this? Yes, concrete made by cement, stones, and sand. Yeah. Table 5 shows about two types of glasses, P and Q. So glass made by what? This one 8.2. Okay. So glass made by sand. Right? It's better if you call it silica. The chemical is called silicon dioxide. Or if you see silicon 4 oxide, same thing only. Okay? It is SiO2. So you see, doesn't matter which glass, you always got silicon dioxide. Doesn't matter which glass. Right? And then, but the other materials might be different. Okay? So P got silica, sodium carbonate, and calcium carbonate. If you see sodium carbonate, right? Sodium carbonate can summarize in one word. We call it soda. Soda. Calcium carbonate, we call it lime. Limestone, right? You know, sodium carbonate, okay, like soda, calcium carbonate, limestone, right? So the P is called soda lime glass. This one cannot tahan heat Soda lime glass cannot tahan heat, cannot 不能趁热 cannot tahan heat. No, So to make like the jug, to make like glass bottle, like your alcohol bottle, this kind of thing Okay. So then Q. If you see silver chloride and also you got calcium carbonate. Now the key point is silver chloride. Silver chloride contain Ag plus. This Ag plus can turn to Ag, can make your glass become darkened. When Ag receive electron become Ag plus receive electron become Ag, this can darken your glass. What does it do? It can block you from your sunlight, from the UV light. This is called photochromic glass. This is another composite material. 8.4 is photochromic glass. Which block like your sunglasses, like when you wear your sunglasses, apply to car window, building window, office window. This kind of thing So yeah, state two similarities of the properties of glass P and Q. Quite simple. So what is the similarities of glass? Chemically inert, yes. A lot of things you can say. Chemically inert. And then some more. Two similarity. Heat insulator. Yes. Then another one. If you don't want also, you can say.
Electrical insulator.
Huh? It means cannot conduct heat.
Electrical insulator.
Electrical can also but normally I don't write Can also actually nothing wrong. Another one is the most obvious one. Transparent, 透明. Right? Yeah, so you got three main one, three, right? Two. If you wish to install a glass window at your house that is able to prevent the UV rays, which type of glass will be chosen? Of course, I talked about this now, right? Prevent UV rays. This one is the photochromic glass, which is glass Q, right? Glass Q. Yeah, you can say glass Q. Even if you say, if your answer say photochromic glass, also correct. Also can accept. Why? It can absorb the UV ray, or you can say the glass is sensitive. Glass Q is sensitive to light intensity. Or you can say glass Q can absorb the UV, the ultraviolet rays. This came up question 10 marks. 10 marks quite a lot. One other uses. Just now I told you, right? Can make window glass. Both can make window glass. So another uses, car window. Or you can say vehicle window, same thing. Vehicle window. Or you can say a camera lens. These two normally. Camera lens. Okay. Okay.